Hello, my name is Janae Savoy and I'm in Q23 and this is my video for hypothesis testing for BMGT 438A. So I'm working with the Spectrum District Taco data and my research question is, out of the two drivers from District Taco that deliver the most, is there a difference between delivery time duration? So I'll be comparing the averages for Alejandro, who drives the most, and Wilmer, who drives the second most. Therefore, I'll be conducting a two-sample t-test since I'll be comparing the sample means for Alejandro and Wilmer. As far as my hypotheses, I have let mu A represent the population mean duration time for Alejandro, and I have let mu W represent the population mean duration time for Wilmer. So our null hypothesis is that mu A is equal to mu W, or that mu A minus mu W equals 0. All this means is that there is no difference between the population mean duration times for Alejandro and Wilmer. The alternative hypothesis is that mu A is not equal to mu W, or that mu A minus mu W does not equal 0. And all this means is that there is a significant difference between the population mean duration times for Alejandro and Wilmer. So after I determine my hypotheses, I graph the data using side-by-side box plots. So on the left, you can see that the data for Alejandro is represented in a blue box plot, and on the right, the data for Wilmer is represented in a purple box plot. As you can see, the data looks roughly symmetric, although the data for Wilmer has a few outliers. But just to make sure that the data was symmetric for Wilmer, I decided to run summary statistics. So I used the summary function in R, in which I plugged in the variables that represent the raw data for the duration and time for Alejandro and for Wilmer, respectively. As you can see, in both cases, the median and the mean are very, very close together, which indicates that the data is symmetric. So once I determined the data was symmetric and therefore roughly normally distributed, I decided to go ahead and do my t-test. And for that, I used the t-test function where I plugged in the raw data for Alejandro and the raw data for Wilmer. And I also indicated that the data was not paired. And this is the output that are provided. So as you can see, we have a t-score of negative 0.69 and a p-value of 0.4949. And we have a 95% confidence interval of negative 7.07 to 3.47. The level of significance in this case is going to be 0.05 or 5% because that is the standard level of significance provided by R. And if you want to compare the p-value to the level of significance, you can see that the p-value is really, really big compared to a 5% level of significance. Therefore, we know that we can fail to reject the null hypothesis. We can also tell this by the confidence interval. Remember that our null hypothesis is mu A minus mu W equals 0. And since 0 is in the 95% confidence interval, that's also evidence that we should fail to reject the null hypothesis. Therefore, we can conclude that at a 5% level of significance, that there is not a significant difference in the average delivery duration time for Alejandro and Wilmer. Thank you.